Oh, this is so cool. Is it touching Saturn yet? Or are they just kind of going into the planet? It's like an egg. It's like a little egg. Hello, everybody, and welcome back to Universe Sandbox 2. It looks like we had a new update. It just made some improvements to the galaxy simulations. I don't think anything super new there. It runs better, so we'll try to maybe play around with those a little bit more. And they added a introduction. They added a tutorial, I guess, to teach you how to play Universe Sandbox. And they included a simulation for an asteroid that almost hit Earth, and we didn't know about it until the day before. So imagine the movie Deep Impact, where they knew about the asteroid maybe a year or two before it was going to hit us. You get one day, and a giant asteroid is going to end all of civilization. So there's not really a whole lot of time to panic there. The whole point of me jumping on this game right now is I finally updated my graphics card, because in the last several, maybe like 5 to 6 videos, I've been running into performance issues on my computer, and I haven't really been able to make any crazy simulations. But now I've gone from a 980 Ti to a 2080 Ti, or an RTX 2080 Ti. I don't think there's ray tracing at all in Universe Sandbox. I can check. But I'm going to try and just test the limits of my new computer. Not new computer, but I'm going to try and test the limits of this graphics card, and maybe we can do some crazy stuff now. But first, I wanted to check out this new simulation. I want to see this asteroid that almost hit us back in July, the end of July, a little over a month ago. All right, well, okay, this is happening now. So this is OK's trajectory, and this is how close. Oh my God, hold on, pause. So this is the asteroid. Let me focus in on this thing. This tiny asteroid. I mean, how big is this thing? Okay, so we have a little bit of a rock. Who knows if it actually looked like this? Maybe they're just using some default model. Unless they actually made... let's see here. On July 24th, 2019, astronomers detected and announced the discovery of asteroid 2019 OK. Is it just called OK because we're all right, we're good. Mere hours before it's the closest approach to Earth on July 25th. With a radius between 30 and 65 meters, 2019 OK is the largest object to pass within the moon's orbit so far this year. Okay, so it was closer to Earth than the moon was, and that's the trajectory right there. This is actually super close. I mean, the moon is already far enough from Earth, but you can imagine the moon in the sky, like, you know, it's an absolutely huge object, so it looks pretty big in the sky. Even though the moon is actually a pretty comfortable distance from Earth. I mean, look at the size of the moon and look at the size of the Earth if you want to squint a little bit. But this is like a tenth of the distance between the Earth and the moon. It's going at 129,000 kilometers per hour, just smacking right into Earth. And what's the mass of this thing? The mass of this thing is, well, that's in kilograms. How about the mass of the moon? Okay, nowhere near the mass of the moon. Yeah, I guess it's that many kilograms. That is big. Let's see if we can actually get this to collide into the Earth. So we'll move it this way, and then we'll move it up. It's gonna slam right now. And then that would be the impact if that asteroid actually hit us. I mean, according to the game, I mean, you know, it may not be 100% accurate, but it just slammed into Earth. It made a crater about that huge, and it created a shock wave to be There was even a fragment that actually went back up into orbit, and then it crashed right back down onto the planet. So you're actually going to see lots and lots. You're actually going to see lots and lots of mini impacts. It's like the planet just got carpet bombed a little bit. And it may even just be fragments of the Earth that kind of just got shot up into the atmosphere and then came crashing down again. Because that is a lot of kinetic energy just getting thrown into the planet, but it may not be enough for it to be a world-ending disaster. And also, we kind of nudged it into like the ocean. I guess it's more likely to hit New Zealand. You know, if it could have hit Australia too, or somewhere in the Indian Ocean. I'd say it's more likely, if that's actually where the Earth was facing, it would probably hit the ocean. And then there would probably be tsunami warnings in Australia and pretty much anywhere along the Pacific Rim, because that'll just create a shockwave throughout the entire ocean. Okay, so there's planet Earth. It's going at, I don't want to go at 1 hour per second. I just want to go in like a minute per second. Let's just fling an Earth at Earth, and let's see what happens. Back to basics. Earth crashing into Earth. What's that gonna look like? Boom! Smooth Smooth, smooth. And very nice explosions, too. Let's speed this up. Then the newly formed Earth will recombine itself. That actually looks like a pretty cool view right there. I like that. It looks like it's getting bigger, but really it's just being flung right towards us. Let's see how many Earths I can get. How many Earths can we... Let's pause this and we'll just spawn a bunch of Earths and maybe we can have a nice, smooth, and insane simulation. Let's make Earth orbit Earth in a binary fashion, and let's have this Earth orbit this Earth, and have another Earth right here orbit this Earth, and have an Earth orbit this Earth, and have an Earth orbit this Earth, and have an Earth orbit a lot of these Earths, and then, you know what, let's just have an Earth orbit super far out. Bunch of Earths just chilling. I'm fully expecting a smooth simulation. Nothing bad's gonna happen here. Let's go. Explosions. Explosions. Ooh, I was actually getting a little bit of lag right there, but it's not too bad. Oh, it's beautiful. Beautifully crackly, but I am not seeing a frame in sight dropping. We're back, baby. We can make crazy simulations again. Let's see if this, let's get a random elliptical galaxy. So how do you look? And if I just let you sit here, do you move at all? Yeah, okay, everything's moving around in here. All right, let's get rid of all of these trails. Let's get rid of that. Okay, so that's how that looks. So that's, this is a good time step for this galaxy. And now let's have a random irregular galaxy spawn right next to it, and let's see if they interact with each other at all. Maybe they will. I don't know. Maybe they're not close enough. Oh, they're going towards each other. Okay. Wow, look at that. Not a frame dropped. It wasn't really the prettiest interaction, but maybe we can get another guy to butt in here and then he can join the dance. Actually, they're kind of just orbiting around each other now. Let's focus on this one. Look, I can't try to figure out what it wants to focus on. Actually, this is a big galaxy. All right, let's get the big galaxy in here. And that one's just gonna kind of consume these guys. Yup, everything's just been kind of dispersed at this point. Let's add the Andromeda galaxy. What if we put the Andromeda galaxy and the Milky Way galaxy in kind of like a binary orbit, and they're not actually colliding with one another? So let's see if they actually will orbit each other, and maybe they'll just... Ooh, okay. It tried to orbit. That seemed like a much more accurate depiction of what would happen if both of those galaxies collided, but they didn't orbit. Can we actually try and get a galaxy to orbit? Or will we just end up kind of spaghettifying a galaxy if they're in orbit, because they're not really like a solid mass object. It's just like a group of mass. It's just like a group of massive objects, if my way of describing that is okay. I mean, we can try doing it with 2 Milky Way galaxies. Let's put these 2 Milky Way galaxies in a binary orbit with balanced motion. And they're not really touching each other, so hopefully they're not just going to tear each other apart. So they're both just kind of chilling right now, not really orbiting each other. Oh, they're getting closer now. Slow it down, slow it down. Yeah, it seems like they have a problem when it comes to orbiting. They don't want to orbit each other. They just want to go directly into each other. That's really weird to me. We're having some interaction here now, and then they're going to explode and get rid of this menu. I don't want to see the menu. I want to see them kiss. Ta-da! Oh, they formed like a double galaxy for a second. You guys saw that? Like for a brief second, it turned into this, like, there were 2 centers and it changed the shape. And then it just went into this big mess and it went poof. Put this in like a binary orbit right here. And then what if we just got our own sun? And then we made our own sun orbit Vega. And then what if we had another star kind of orbit, another sun orbit right here? Let's just try and make like a really, really, really big system with a bunch of stars that could be kind of balanced, hopefully balanced, because obviously once we trigger our first supernova, then everything's going to be thrown out of whack. Have I done this before? Well, we don't want to just introduce Betelgeuse into the mix because then I think things will certainly pop. How about Alpha Centauri? How big are you? You're kind of like a smaller star. Let's put Alpha Centauri out super out here. And then we can get Alpha Centauri B and have it out here. And then maybe we can... I feel like as soon as we put a star out here, then things are going to go really, really out of whack. Actually, hold on. Things are already starting to go a little out of whack right here. Our sun is already starting to drift, and he may even go over here. Oh, boy. Or maybe not. Maybe not. Let's try to speed this up. Oh, no. No, Vega's going to crash in something, and... Oh! And... Pop! And then, the only stars to survive are Alpha Centauri A and B. But, no lag. No lag whatsoever. I mean, stars don't produce that much lag at all. Yeah, then Alpha Centauri A and B are destined to do this forever because that's how they actually are. Or actually, I think Alpha Centauri, the Alpha Centauri system, that's the closest star system to our solar system at I think about 4 or 5 light years from us. So that would be like the most realistic place we could visit once we can unlock interstellar travel in our IRL tech tree on planet Earth. That's probably the star system we would visit first, just so we can say we did it. First humans ever to go to a new star system and back. We probably wouldn't go back. It would probably just be some probe to send pictures. And then, of course, we wouldn't see those pictures for 4 or 5 years once we take those pictures. So that would be a very, very long trip. Unless we manage to do some weird warp drive stuff. Or maybe we can get the ship back theoretically quicker than the speed of light, but without actually breaking the speed of light because you're manipulating space-time around you. Ooh. Yeah. Ooh, this would be the kicker. Yeah, let's get Saturn, and then we'll add some rings. Let's just add some Saturn rings. I want to add a ring to you. Add a ring to Saturn. Okay, Saturn's looking pretty nice. Then what if we add another ring to Saturn? Awesome. What if we add a third ring to Saturn? Yep, make Saturn's rings thick. Okay, that's actually kind of getting a little bit laggy, huh, man? Okay, well, what if we just disrupt this a little bit since we have many, many particles? Let's slow it down, and then we're just going to shoot something really, really quick through here. Pluto? Pluto's pretty small. Yeah, let's do that, but we're going to launch Pluto at a very high velocity. We are not doing auto launch velocity. We're going to do like 5,000 kilometers per second. Shoot Pluto through Saturn's rings. And it's probably going to, let's just do 9 seconds per second. Okay, there we go. That's actually pretty good. That's a good speed to do this at. Kind of like my my neutron star or my pulsar experiment where I had it kind of just fly super close to Earth and see how that would affect the planet. Okay. Pluto just flew right through Saturn's rings at an incredibly fast speed. And so far, no immediate effects. I hope you're jotting down this information, my fellow scientists. But if we increase the time step, maybe there was some kind of influence. If there's not going to be anything, I'm going to be greatly disappointed by that. There has to be at least some kind of ripple, right? We may have just did it way too fast. And also, to be fair, Pluto is kind of a weak planet. Don't tell Pluto I said that, but Pluto's kind of a weak planet. Absolutely nothing. That is a straight disk. Pluto just whizzed right through there with absolutely zero influence. You hear that, Pluto? You have no influence in this system. Crab Pulsar is pretty small, but the mass is huge, and it just, as you can see, it changes all the lighting. So they're very, very small. It's the mass of 1.4 suns, but has the radius of 11.5 kilometers. So very, very tiny, even smaller than Pluto. But the mass should be enough to influence these rings. And it may be massive enough where the rings are immediately just going to start flying towards this thing, which will be very cool to look at. And it's going to get closer and closer and closer, and gravity is going to get a lot more exponential, and we may start seeing some of these things starting to rise. Ooh, I'm surprised I never thought of this. Adding rings to the mix of this experiment. Is there any warping yet? Oh, wait. You see that? Look at that warp. Look at that. You can see that. It's moving. The ring is now being drifted towards the pulsar. Oh, that is cool. Okay, and freeze. Look at that. Look at that. If that is not a good way to illustrate the effects of gravity, like the most immediate closest points are being influenced more than the others. Like you can almost see the mathematics behind that. Just the variations of strength based off of distance. My description of that is horrible, but I think you know what I mean. It's like you can see the gravity happening by. It's like mocapping gravity. You're seeing every single point and how everything is being affected. And then it's going to go through and we'll see what the effects are when it goes through. Oh my God. And they're just kind of swinging around the pulsar. I want to follow the pulsar through this. So it probably has like a bunch of rocks like trying to orbit around it. And now everything is going to start getting messy. Yo, I hope you guys can see this. It's going to be disappointing if you guys can't even see anything on my recording, but it looks beautiful to me. I'll try to do as much post-production as I can. And then we'll watch it go right through there, and then everything is gonna go all out of whack. Look at, whoa! Okay. Whoa! It's creating a bubble around the pulsar. Okay, I did not. See, I underestimated the strength of that pull. It immediately created a bubble around, like it pulled all of these particles in the sphere of influence of the pulsar, and it's probably just going to steal all of these fragments. Jesus, Saturn just lost all of its ring. What is that I am seeing? What are these rings doing? I don't have an explanation for that. I had an explanation for the sphere, but I don't know what is that just like the result of Saturn just getting pulled so far away from the rings that like now these rings are all stranded? Oh, that is awesome. Let's get the crab pulsar again. That was a good dummy, a good experiment. Launch U. I don't want auto launch velocity. I want to go once again at 5,000 kilometers per second. That was a good speed. Let's go. Let's make this slower. We'll have one crab pulsar launch through this side, and we'll have another crab pulsar launch through this side. So both sides of Saturn, and hopefully these crab pulsars aren't close enough where they're going to influence each other, and maybe they'll just end up swallowing Saturn. Who knows? But we should be able to get much better lighting for this one at the very least. So we're closer. We're going to start seeing some influence from their gravity if it already hasn't happened. This isn't looking like a straight line, so I'm already noticing some warping. Let's speed this up again. Yep, and now the warping has begun. There it goes. Oh, that's so cool. And it's going to be the same thing on this side, probably. Actually, the one on the front side is going to be approaching quicker, or before the back side. All right, there's the back side. Here's the front side. Now the pulsars are making their ways through the rings, and then they're just going to end up leaving. And then we're going to be left with rings being completely disrupted. This almost looks like a magnetic field right here. I'm talking like, ooh, oh, we had a different effect right here. Look at that. That caused a good portion of Saturn's rings to just collide right with the planet. That's really awesome. God, who does that look like? Is that Samus? Samus, it's someone's face. Yeah, and that just caused everything to break up, and we're getting that spherical look again. Yo, that is awesome. And then that ring is still existing around the pulsars. It's probably pulling the sun. Yeah, you can see the sun moving in this direction. And thankfully, since we have the sun now, we can light up all of these particles, and you still see that sphere. And then, lo and behold, notice how the pulsars are the center of that sphere that you're seeing. And that sphere is just getting bigger and bigger, and now it looks like it's probably going to get disrupted because the pulsars are just kind of flung around each other. So it's probably going to end up making them diverge out a little bit more. So no more sphere, and they're also getting further and further and further away from the sun. God, that is so cool. It's just a nice, elegant dance in space. In harmony. It's very satisfying to look at. For my last experiment, I'm going to try and see if I can increase the mass of this thing. Maybe if I just, what happens if I just turn this to the mass of 5 suns? Will it get even bigger? Or did we turn this into a black hole? Let's see, let's zoom in, zoom in. Okay, so we turned this into a really, really small black hole. But can we make it like even bigger? I want to make sure I wonder if I can turn on radius lock. Can I lock the radius to make sure it doesn't get any bigger? Let's just see how much we can increase this by. Okay, that made it 148 kilometers, but 148 kilometers is still like, that's still doable. The mass of 50 suns. What if we make it the mass of 100 suns? That'll make it 300 kilometers. 300 kilometers is probably fine. What about the mass of 200 suns? And that makes it 500 kilometers. So it's a much bigger radius, but it's still so small in comparison to the size, to the radius of Saturn, which has a radius of 500 kilometers, and this, oh, sorry, 5,000 kilometers, actually 58,000 kilometers. It's getting there. I probably don't want to get much bigger than that. So it's still kind of like a pinhole going through Saturn's rings, but the mass is that much bigger, and I want to get some extreme gravitational pulls on these rings. So let's speed this up. We're probably going to see some influence much earlier on, maybe even like around now. Even though it's this far out, the pull will be that much greater. Oh, here we go. Oh yeah. I'm already starting to see this ring warp towards this thing. Well, there's Saturn with a nice bent ring right here. A little short side. Is this thing still moving? Yeah, we're still kind of inching towards us, but it's gonna happen quick. Oh yeah, there it goes. Actually, you may even have the ring just kind of collapse right into Saturn. The ring is getting like spaghettified into this thing, and that makes sense because we're dealing with a black hole right here. This is cool. It's condensing so hard right now. Oh my God. Oh, this is so cool. Is it touching Saturn yet? Or are they just kind of going into the planet? It's like an egg. It's like a little egg. Oh, it's still pulling towards it too. All right, let's get into the perspective of the black hole now. Oh, this is sweet. It's like outgassing. What's all this gas? There's gas like surrounding the black hole right now. Are we gonna like start sucking up Saturn? Okay, well, we have some rocks flinging right past the black hole. Whoa, my God, it's like getting an insane assist, and it's gonna end up going right back into Saturn. Oh my God. Okay, let's speed it up a little bit more just to see the full effects of this thing. So it's gonna make its way through and just start spreading them all over the place. It just ate Saturn. It deleted Saturn, and now it's just gonna suck up the rest of these things. All right, so I guess it was a little bit too big. Or I think actually what happened is the black hole didn't get pulled towards Saturn. Saturn got pulled towards the black hole. It didn't matter if this thing was traveling at 5,000 kilometers per second. It was... Ooh. I'm sorry, I lost my train of thought because that's really cool. So everything whizzed by the black hole, and it just formed this elegant formation. And everything just kind of stopped. And is the black hole just gonna be on its way? It's just gonna be on its way. And we're just gonna have this floating ring, disrupted ring structure out in space. Is it gonna at least like spread out a little bit out here? All right, let's just delete the crab pulsar. We don't need to deal with that anymore. Oh, yeah. Okay, the rings are just flying out into space. I want to focus on this stuff. So now we no longer have Saturn. We just have rings. And yeah, they're just going to kind of spread out in the formation that they're in right now. And that's going to be the end of them. But yeah, I think that does it for today. I was just kind of testing out the graphics card, and that's spiraled into an experiment with rings and pulsars and black holes. So I hope you guys enjoyed, and I'll see you all later. it would probably eventually regroup because it's a bunch of emptiness, and the nearest massive object, even if they're millions and millions and millions of miles away, there's still a gravitational influence, even when something is millions and millions and millions and millions and billions of miles away. It's still there to a degree. It's like an infinitesimal amount.